So this is going to be a short video on testing the rectifier in your old style HTP MIG 140 or 160 or 200 or 2400. They all, not all of them, but some of them have slightly different setups as far as the rectifier goes. This is the rectifier in the 140. It's got these little air-cooled heat sinks and these replaceable diodes. Older style MiG 160 looks very similar, just bigger. Same thing, replaceable diodes, big air-cooled heads. And then some of the other machines you'll see have a bar and plate design, and these are a little bit cheaper, but they don't have replaceable diodes. The diodes are press fit, so this whole thing will get replaced if it happens to be defective. What you're looking for are the points of testing when doing one of these is you want to look for the AC in and the DC out. So your AC in is going to be coming from the transformer. So you would have positive and negative here, or your positive and negative probes would go here, and then your DC out is going to go to the condenser bank. So you're going to be looking at here, and here will be your points of testing. On this one, same thing. Your transformer wires here and here, so in and then out here and down here. And on this 140, you got your two in are these guys here and here, and then your out is going to be here, and your negative probe is going to be here on the heatsink. Before starting this test, you're going to want to take the tension off of the wire feeder. You're going to have the trigger engaged to do this test, and if you don't take the tension off the wire feeder, when you engage the trigger, you're just going to be feeding wire everywhere, and it's going to be a big mess. When you're doing this test, you're going to need to have the trigger engaged, so you can either have somebody else hold the gun and pull the trigger when you need, because your hands are going to be working the meter, or if you don't have somebody else around, you can turn on your pause time, and then when you engage the trigger, the machine will stay running until you hit the trigger again. Okay, to test the rectifier on the MiG 140, you're going to first have your voltmeter set to AC volts, so it's going to be the V with a squiggly line. It'll say AC in the display usually. And for this one, the 2 points are going to be this bullet head back here and this one on top, and you can see on the meter we're getting nothing. It's because when you do this test, you have to have the trigger engaged and the machine has to be live. So testing again, we're getting 36 AC volts, so we have power in, and again that's coming from the transformer. And then for testing out, we have to switch to DC volts, which is a V with a little straight line over it, and we're going to test on this volt here against the heatsink, and we're getting about 24.5 volts with a little bit of voltage drop. That's normal. Okay, now we're going to test the transformer in an old MiG 2400 that has a bar and plate design rectifier. And again, first test is going to be AC, and we're looking for the two wires coming from the transformer, and the machine has to be engaged. The trigger has to be engaged. We're getting about 13.8 volts in, and we're going to switch to DC, and then volts out, we're going to go here and here, and we're getting about 21 volts DC out. One last important note when it comes to testing the rectifiers Your output voltage that you're measuring, you know, say when you're checking the DC out on the rectifier, the voltage value is going to change depending on where you have your power switch setting. So depending on which of the windings in the transformer you're using, you're going to end up with a different result as far as your voltage reading. But what we're really looking for is to find out that you have a voltage reading. If you don't have a voltage reading, try changing this, because you may just have a dead spot in your power switch. If you change it and you still have nothing, then it's possible one of the diodes is malfunctioned. Another thing to note is that on this one, you'll notice that there's a voltage drop, from input to output. And on this style, there's a voltage increase between input and output, and both of these are completely normal. And it's just wholly dependent on the engineering and how the components are arranged.